Awesome. All right. Welcome, everybody. Thank you for coming. Today, we're going to be talking about the blockchain integration framework. Originally, this talk was supposed to be given by Giuseppe and Peter, but unfortunately, due to travel restrictions, Giuseppe was not able to make it, so you all are stuck with me instead. So let's get started. Today, we live in a world of many networks, as many are probably familiar. As an example, here's the internet in some kind of artistic rendering. It's hugely complicated. If you're a business, oftentimes you have to work on many networks. And this is what, say, a network or a collection of networks for a business might look like today. Very centralized, but still connected. So obviously, we're at a blockchain conference. So the question you have to ask is, what about blockchain? Well, in a blockchain, it's going to be substantially more complicated. Decentralization has some cost, and obviously, what we need is going to be a lot more difficult. And many of the blockchains that we're going to replace these traditional networks with are going to have requirements that are substantially more difficult to guarantee than in the centralized world. So as an example, right, some of our blockchains and membership services might need decentralized identity support. If we don't have central servers anymore, this is something we might need. Other blockchains might need great scalability. I'm sure many of you are familiar with the difficulty of scaling blockchains. So we often have to give up a lot of security or privacy properties to get good scalability. Other blockchains or parts of blockchains might need extra cryptography for privacy. Some blockchains might need very fast transaction speeds or good performance. There are a lot of blockchains that need legacy compatibility. And even some blockchains need auditor support, which again, might be very simple or easy for a centralized solution, but more difficult for a blockchain. So what does this lead to? Well, essentially, we sort of feel that there will be no one blockchain to rule them all. We will have to use many different blockchains for many different applications, and there's no platform that's going to be right for everybody. And what does this mean for us? Well, a really important part of this wider network ecosystem is going to be communication between blockchains. And you can see here that I've outlined sort of these different communication protocols between these various blockchains. So this brings us what we're here for today. So with the blockchain integration framework, we intend to define a communication model that enables permissioned blockchain ecosystems to exchange really anything, any on-chain data, any assets, independent of the platform, and without a middleman wherever possible. So we thought about this a little bit, and some of the basic core requirements we wanted are as follows. So we want a system that's maximally pluggable and maximally general. This will sort of minimize future work. We want to eliminate middlemen whenever possible. We don't want to have to go through and implicitly trust intermediate blockchains unless we absolutely have to. We don't want to use a token. When we're building software for enterprises, we really don't want to mandate that our clients or customers use tokens. And finally, we don't want to mandate a toll booth. We don't want to require operators to have to make money by taking a cut for intermediate transactions, as in many cases, the incentives are aligned for people to complete interoperable transactions. So what does the interoperability space look like today? Here's a moderate assortment of current solutions in the space. But unfortunately, none of these existing solutions sort of satisfy the core principles we mentioned earlier that are essential for the enterprise use cases. So fundamentally, we came to the conclusion that we needed a new way of doing interoperability. And this is where collaboration comes in. So we at Fujitsu and Accenture sort of independently came to these conclusions that a new interoperability solution was needed, and we sort of both built our own. So once we all realized that we wanted to open source our solutions, we decided it would be more efficient to work together than to continue on with our separate solutions. So our current status is we have 2 independently working code bases for interoperability, one from each company. They're currently open sourced in Hyperledger Labs, and you can see them and play with them for yourself. And we're in the process of merging the code together to build a best of both world solutions that we think will give us all of the use cases of both code bases. And you can see, some sort of work in progress diagramming of what our interoperability solution might look like. So the question you might have is, what does a general interoperability platform need to look like, and how can we go about building it? Is it possible? And with that, I will turn the presentation over to Peter.
Hey everyone, I'm Peter Somogyvari. I will talk about the rest of it. So first and foremost, we need wide support. If we want it to be successful, people need to use it, and people have a lot of different requirements, so we need to try to capture a lot of those together. It also has to be pluggable. I'll return to that later in a lot more depth. Where applicable, we want to prevent double spending, of course, but that's kind of a can of worms, and it's not always strictly possible. So we just want to make sure that when it's possible, then it has to be done. And then the features of the ledgers. If you have a ledger that has something unique that most other ledgers don't do, we don't want you to lose that. It has to work with the blockchain integration framework. And last but not least, it has to be low impact. We don't want to force you to have to fork the code base of some ledger that's out there just so that you can work with the integration framework. There's a complete list of these in the white paper, so I'll keep returning to that. I highly recommend that everyone, if you have the time, you look at the white paper. We will provide links for that. So one of our core components is the interoperability validator. It's basically a server-side application that sits at the deployment of your ledger and the software stack that you chose to operate it with. And it provides you with high availability through an overlay network. Currently, it has leader elections built in, but we're planning on removing that. The network services that a validator will give you on a high level is basically to handle your export requests. An export request is when you have a piece of data on one ledger and you want to move it to another ledger. Also, the big feature there is to be able to verify the state of one ledger on the other one. And we achieve this by managing the trusted form validators, essentially just putting or dispersing public keys of the validators on the ledgers within smart contracts. Some technical information that you should be aware of. Our code is in JavaScript, but through the plugin architecture, we plan on supporting different languages as well. There's some great patterns out there. One that we've seen is how the Go plugin project implements it. They can, you pass in a command line argument that starts a binary. The binary ends up listening for gRCP requests, and your actual core software that interacts with the plugin, it communicates with that other binary through that gRPC. And then in this structure, it doesn't really matter what you use to implement your plugin. It could have been any language that had support for that API. This is one of our example use cases. There's many of them in the white paper. You should go and read it. I'm not going to go into too much detail here. I'll just highlight the beginning of the sequence, which is proposing the transaction. That's where you get to specify the constraints of the transaction, as in how do you want it to be handled? Should there be an escrow? If you are transacting with a permissionless ledger, then maybe you want to put a limit in there for the number of blocks that you want confirmed before the transaction can be finalized on your end. And also it demonstrates greatly that BIF, the blockchain integration framework, is a common API layer in front of other ledgers. In this example, Fabric and Basic. So the architecture-wise, what you need to implement yourself is you have to either connect to somebody else's ledger or run your own. That's entirely up to you. You need that ledger's SDK, and then on top of that is the abstraction layer. That's us, the blockchain integration framework, which you can use for the validation services and the data export. And I will show a really quick, really simple demo that's just with a rudimentary made-up asset being transferred from one ledger to the other. I will demonstrate that signatures can be verified in cryptographic manners so that you actually have proof that the data that you transferred from one ledger to the other is as it was intended to be. And it will be a live demo running from a box from my living room, so if it did crash, I apologize. I also have a video of it. So what you see on the left side, it's DLT1. It's oh, apologies. What happened there? Yes. So what you see on the left side in the pink or magenta color, it's DLT1. It's a bunch of containers running Fabric and the BIF validator nodes, and an API server that has some endpoints for the actions that I will be presenting here. The other side, it's pretty much the same blueprint, but that's Quorum. So you have two sets of validators in this imaginary scenario with two separate organizations running their own ledgers and their own BIF deployments that can communicate with each other, and data can be exchanged between the different ledgers. So the way it goes, you can create an asset which calls the API, which then calls BIF, which calls the smart contract deployed on Fabric. And if it works, it does. There's just a JSON representation of some dummy data. It's an asset. It kind of represents some sort of token, but it's not a real token. Then what you can do, you can modify the data. For example, if you want it logged so that you have proof that on the left side of the ledger, this data will be sort of discontinued, you can issue a lock request. You can set additional parameters if you like. It's all just JSON. You can, you could put in there who's going to receive this. And at this point, the data exists on Fabric, so you can ask our validators to provide signatures for that particular piece of data identified by the asset ID, which is it's a primary key in database terms. So when you hit that endpoint, the validators perform a broadcast on our overlay network so that every validator that's up and running will produce the signatures. Then in our imaginary business application, at this point, you want to send over the data, and you can choose to send it with the correct or the wrong signatures. I will choose correct, but if some of the containers have died, then this may not work. At this point, you can verify the signatures on the other side, which means the foreign key validator public keys that we have in these BIF validators will be used. And those are the public keys of the validators from the left side. Yes, so it's an array of 4 Boolean values from the 4 validators. It's all true, which means we're all good. At this point, you can just say, okay, I'm going to copy the asset. At this point, we have the same piece of data present on the Quorum ledger, and you can actually query the state of the ledger through the blockchain integration framework. Yes, it actually worked. I'm really fascinated by that. That was the demo. Yes, so under the hood, on the chain, we have the public keys of the validators. That's how we establish the trust, and that's how the signature verification can work. Off-chain, in the REST API layer, that's where the requests are happening for exporting the data and requesting verification of said data. So now with the demo done, I'll get over to the plugin architecture, which is a really, really big fundamental part of what we're trying to do, because nobody knows the future, even if you have, cool glasses like that, which I'm sure will happen in the future. Nobody knows it for sure. So all we can do is try to remain flexible, not produce too many opinions and impose those opinions on our users on how interoperability should be done. And for that, we are trying to pluginify as many aspects of the whole process as possible, so that future technologies, as they come along, we can always just say, we'll just write a plugin for supporting that latest thing. And the plugins are loaded at runtime, again, for flexibility and because JavaScript allows that. And what I really want to emphasize here is the community aspect. We are really community first in our ideas. So the concept is that if you need something supported, you can write a plugin. You don't have to even ever talk to us. I mean, we're really nice guys, but if you don't want to, you don't have to. You can just sit home, write the plugin, put it on GitHub or not, and use it with your BIF deployment. And if you ask at any point in time about any feature, other ledger, algorithm, protocol, if we could support that, the answer is most likely will be yes, we can. And this little chart is what will actually go through our heads. If a plugin already exists for it, we'll just say use that plugin. And if it doesn't exist, but it is in the realm of one of the pluginified aspects, then we'll say, well, implement the plugin, and then you can use it. And there's the edge case where it is an aspect of the code where we haven't thought of making it dynamic and pluggable, in which case we will be happy to take a look at ideas that you have on how to make that pluggable, which would then result in a pull request. And then, if we do accept that pull request, then you can just go about implementing the plugin and using the plugin. So you always end up with using the plugin. As an example, I'll just highlight the storage plugins. It's really there so that if you deploy BIF, You're not tied to your particular database for operating BIF itself. You can be agnostic of that. The interface for the storage plugin is on intention very simple. It may get a little more complicated in the future if we have to absolutely add extra things. But this is just an example where I'm demonstrating that it's simple to implement so that anyone who works with databases can look at this and say, well, I can definitely implement that API interface on top of 99% of the databases that you ever heard of. And what I need to emphasize there in terms of storage, we don't need the storage because we're running our own ledger with tokens, as Hart already highlighted. It's about storing metadata, administrative details related to your transactions. So basically to just keep the lights on. Preserving ledger features, very important, but it also can be a can of worms. If you use two ledgers in your interactions and they both have privacy, which is a great example, then you should have the reasonable expectation that connecting them through BIF will also preserve the privacy. But I have to say there, always consult the security experts. Just like I heard this talk from the Ursa guys, they kept hammering that point home that just because you use a tool that was labeled as secure, it doesn't mean that the way you use it is secure. So that has to be said there. And our main focus really is to not have unexpected behavior. And that works with the transaction protocol where you propose up front the things, the assumptions, and the constraints that you want to have. For example, if you need escrow or if you want to have 10 or 20 blocks confirmed on the Bitcoin mainnet for your transaction to be considered final. And then execute a transaction if both parties said, okay, I can work with this. Yes, I think I pretty much talked about this. We want to avoid surprises. We don't want anybody coming back to us and saying, oh, I paid someone and I did not know that Bitcoin could fork, and it did, and I lost everything I had. That would be unfortunate. We expect the transaction protocol to have different versions over time as it matures. And it's important to defend against downgrade attacks. One way of doing that is to just not allow downgrading the protocol versions at all. But that's something that we are still working on. The bottom line is we want to avoid situations where extra additional vulnerabilities are presented in the code base because you can actually downgrade. We want to make sure that we support batch transactions where applicable. Anybody who work with database software in the open source community will tell you that it's one of those features that gets requested 5 minutes after you upload your code to GitHub if it's not there. Performance and scalability, we focus on not being the bottleneck. Because they're not our own ledger, we should have a reasonable expectation of not being a slower part of the system, since we don't have to deal with persistence as much as the actual ledgers. We want to have published benchmarks eventually, but it's not there yet. And I should mention horizontal scalability, it's a big goal of ours, which is why I mentioned earlier that we're looking to eliminate the leadership elections. So our position in the greenhouse, currently we are a Hyperledger lab, but if we do graduate or when, depends on who you ask, then we could be put in the libraries or the tools, it really depends on who you ask from. Is it the person who deploys BIF? For them, it's a tool, if you're an ops person. But if you are in an enterprise writing a blockchain business application, then as far as you are concerned, BIF is just a library that you use to abstract away some mundane details of the cryptographic algorithms behind signature verification and things like that. We do have a roadmap, but it is subject to change. Currently, we are working on finalizing the 1.0 technical design. I will again emphasize, everybody's welcome to provide feedback. We would really love that, because now is the time when you can have a huge impact on how and what gets pluginified, what's configurable. Later on, it's going to be much harder to change the core. We kind of want to treat the core as similar to the Linux kernel. You know, if you try to submit a pull request there or some kind of patch, you will have a hard time getting it approved no matter what, just because there's a lot of scrutiny around it. It's a non-exhaustive list of our to-dos and ideas. We want to support different identity providers. We may migrate to TypeScript. We may unify the API server and the validator into just one actual piece of software. And we definitely want to have a reference architecture that's actually deployed out there and is usable. The first stab at that is my actual demo environment, but it will get better. Again, the plug for the white paper, it's an early draft, but there's a link there, there's a QR code. Please comment on it. We welcome all feedback. And the more feedback it gets, the more eyes it gets. It's a good insurance against us just not realizing something basic or crucial. We have an OSS community. It's not huge, but it's getting there. We have the bi-weekly unique visitors are in the triple digits. And of course, we are here presenting. We're hoping that this will improve over time. And we are actually going to propose it as a Hyperledger project. And you can look at our proposal document, which we put together recently, under that link. There's more links, QR codes. Come to our Rocket Chat. Just message on the channel. There's a channel with a link. Or message us directly. It doesn't matter. You don't have to ask. Just blurt it out, whatever you have to say on topic. Same links, just not with the QR codes. And does anybody have any questions? Mick? Yes. Mick is asking if we could go back to the transaction flow slide.
So what happens, and what I'm really trying to do is to just get a feel for what the trust relationships are that I have with the users have with BIF. What happens if BIF decides to go away right after it sends the funds to escrow, the first transaction to the basic ledger, and it gets it back, and BIF decides, we've already sucked your resources out, now we're going to go away. So there's a denial of service because the transaction never finishes, but the assets are half paid. How do we manage, what is the trust relationship that the users have with BIF? How are you managing these denial of service attacks?
So the escrow should be configured in a way that it times out. So if it
Which presumes that the ledger has the ability to express the transaction.
yes.
So there's a minimum functionality that would be required out of the ledger that you're giving interoperability over, which is it has to have some notion of timeouts.
For this particular use case, yes.
And also the cause of the white paper from Fujitsu. We are expecting to do some sort of exceptional handling, like in the case of the timeout or any other what's happening. Some of the application layer determine to the how to solve the problem. Like like you mentioned, the escrow, the asset should be returned back to the original owner, or some sort of such a handling.
And I say that because your customer comparison protocol, we talked about how we've gone specifically in the video project to make it so that there is no potential for it to not service the time. And then therefore mechanisms might be like that.
Yes.
So
Yes.
that might be the case of the architectural things, like how we can use our tools.
Yes. There's a different trust relationship with the third party that in our assumption. But
Thanks for your presentation. If I understood correctly, the interoperability validators are painted, right? The consortium that chooses the validator that we would we assume that those validators can be misbehaved? And in that case, what happens?
Okay, the question is, do we assume that the validators can be malicious or misbehaving? So trust with the validators is implied. There's consortium management features that we're also running ideas about. But for now, the idea is that you as an organization, you trust your own validators because they are on your network and you administer and operate them.
Yeah, and it's relatively straightforward to configure validators, right? So like a traditional blockchain, you have to trust some supermajority, but you don't necessarily have to trust all of them.
I have three questions. One is about the traceability of the transaction. So when you're bringing a transaction across into another network, is there a way to link it back to the original network other than that you've got, like the keys that are validated, but you don't really, I didn't see any metadata in there that would say, this originated on, whatever the network was and version of the protocol. So I wondered if you were thinking about that. Also, I wondered about cryptography. So do we need some symmetry between the crypto libraries, or the curve keys, or have you been thinking about navigating different crypto libraries or upgrading to future versions that may use different cryptography? And then finally, I guess related to the denial of service, how can we protect against man-in-the-middle attacks and poisoning of the data as it's moving in between the networks? Particularly when that coffee phase where you've had the validation take place, but what's to prevent me from going in there and injecting some false data at that point?
Okay. I'll start with...
Yeah, sorry for... Sure, if you want to answer.
So
Okay,
I'm trying to answer so many questions. So anyway, the summarize it would be first of all we need to share about the idea of the interoperability is not covering to the whole network. So it's let's say that is kind of the independent the contract between the involving to multiple ledgers. So that does not have to be consist with one context to the others. But when we need to interwork for the two ledgers, that has to be consistent, including to the exceptional cases. So the trust for such an intermediate would be some sort of the trust point to achieve or to execute the multiple transaction, or maybe that is kind of series of the transactions. So I hope it will answering your questions.
Somewhat.
So I can probably answer your cryptography questions. So we don't have to use exactly the same cryptography as long as we know each other's protocols. So if you want to use Pick your favorite elliptic curve. You want to use your favorite elliptic. Say you want to do a BLS signature. You can do that as long as I know, as long as I know your protocol and I can verify it and I can trust it. That's fine. Maybe I want to use one of these fancy new post-quantum signatures like Falcon. I could use that, and if you know the protocol and you can check it, then that's totally fine. So we have to know each other's sort of crypto if we want to be able to interoperate, right? And if you're using a crypto algorithm that I don't consider secure, I might refuse to interoperate with you, right? But in theory, this shouldn't be a problem.
And what I could add to the first question regarding metadata and transaction traceability, I'm not sure the font size is good enough or big enough, but there is an origin object in there that shows what was the origin DLT and what was the origin asset ID. And those are all just arbitrary properties we added to our asset definition to demonstrate exactly the traceability. But the idea is that you can define your own assets and conduct that however you wish to. If you have existing tracing systems, something like Zipkin or Jaeger with Elasticsearch, you can always put a UUID in there or a trace ID, from the open tracing specifications.
Yeah, to follow up on that, most of our use cases don't involve moving assets between blockchains. They involve sort of swapping an asset on blockchain A for an asset on blockchain B. So this, this is our most common use case. But what you've certainly, what you've proposed is certainly viable. And if you wanted to add, metadata or something to an asset, to an asset class, you could certainly do that. You just have to, be a little bit careful about how you define the asset.
I guess the challenge is going to be global discoverability. So if you move assets across different chains,
Right, exactly.
where did that asset actually go?
And you're exactly right. And this is why we've mostly tried to focus on solutions where the assets don't change chains. Because as you correctly point out, it is a big problem if you don't know where something is.
Any more questions?
Well, I think we're out of time.
Oh, okay. No
So
more questions. Sorry.
we'll be outside and happy to answer questions if you're still interested or have more questions.
Yep. That's
Thanks
right.
for your time.
Thank you.